Hi everyone. In this video I would like to give you an introduction to section 7.4 from Math in Our World. This is a section talking about the topic of linear programming. This is one of my favorite sections to teach, and it's a longer section, so I'm going to break this into actually 5 different videos. In the first one I'll just give you an introduction to what this is in case you've never heard of it before, and then we will do an overview of a linear programming problem so you can see the process overall. Then I would like to do 2 videos breaking this down and looking at the different steps involved, and then finally we will do several examples of whole linear programming problems just to remind you again of the entire process overall. Alright, let's begin. Linear programming can be traced back to 1947. It's a World War II, has background in World War II types of problems. George Dantzig is the person who is primarily responsible for research and development of this type of mathematics problem. So the problem that he was working on was allocating supplies for the Air Force, and some of the goals were to minimize the cost of distributing all of those supplies while also still distributing them in an efficient way. So linear programming can handle logistic problems in the military, things like transporting personnel and equipment, and then these techniques are used today for businesses. For instance, a business who wants to maximize their profits while still dealing with some limitations on those profits would use linear programming techniques. So some of the goals that you'll see over and over in these situations are finding cost-effective solutions. So minimizing cost, maximizing profit, and then dealing with just limiting constraints in the problem. So for example, in World War II, they had to deal with the fact that there were a limited number of supplies available, and they had to figure out how to fairly distribute those in an effective way. So here's a quote. I'll reference this book and I'll post this for you so that you can see. This is a book called The Introduction to Operations Research, and it's kind of what it sounds like, just operations or companies, and then research into solving some of these problems that they may come up against. So the most common type of application now for linear programming involves the general problem of allocating limited resources among competing activities in a best possible way. And we call that best possible way an optimal way. Sometimes this means a maximum profit, sometimes it means a minimal cost, or sometimes it means a minimal risk. So maybe for the Air Force, they wouldn't want to send all of their supplies to the same base just in case there were, an issue with that base. Maybe the security is compromised, or ultimately something tragic happens and that base is no longer in operation. Linear refers to the type of functions that are used. So we're actually not dealing with anything more complicated than lines in solving these types of problems. Then programming refers, it doesn't really have anything to do with computer programming. We're using the meaning of the word, which involves the planning of activities to obtain an optimal result. So programming as in planning things. The goals in one of these types of problems are to mathematically describe the goal of the problem as a linear equation. So if the goal is to maximize profit, then we might write an equation that represents profit. And you've seen examples of this before. Maybe we're talking about like ticket sales for an event, and we have $10 student tickets plus $15 regular admission non-student tickets. Maybe for cost, we could write the cost as a linear equation. Let's see, cost for like renting a house. maybe it's like $800 a month, and then maybe there's an additional $300 security deposit. Okay, so that's one goal. Describe the goal of the problem as a linear equation. We also want to mathematically describe the constraints of the problem as linear inequalities. So here's some examples of constraints. Is there a budget to follow? Are the resources limited? Does supply and demand create restrictions? So people are only purchasing so much of a product, say per week, something like that. And then do you want to limit the risk by not using all of one thing? So for example, let's say a company produces two kinds of cat food, X and Y. Well, maybe they haven't tested, whether or not cats like product X. So even though it's more profitable, maybe they decide to also produce some of cat food Y, just in case the cats don't like cat food X. And then once we have mathematically described the goal of the problem and the constraints, then what we want to do is find the optimal value of the objective, so for instance the maximum profit or the minimum cost, that's still within the limitations of the problem. All right, and we do this by looking at a graph. So let's say that you've graphed all of your constraints as inequalities, and maybe they all kind of intersect. Right, and we find out that any values in here are going to meet all of those limitations. Well, then let's say you have this profit line, and profit does increase. Profit does increase with the more of, say, a product that you sell, but you can't just make an unlimited amount of product. You're restricted by the number of employees working, the amount of time available in the factory, things like that. So we want to take those limits into consideration and then just choose the maximum value for profit that still meets all of those limitations. All right, so here's an example. A sports equipment manufacturer wants to maximize profits, but there's this limitation on the employees. Each employee can only work up to 40 hours per week. Due to a shortage of aluminum, only a certain amount is delivered each week, and due to consumer demand, there's a limit on how much equipment can be produced each week. So we have 3 different restrictions here that are limiting that maximum profit. Here's some vocabulary terms that you'll see show up in each of these problems. A constraint. We've talked about in real life the realistic limitations on the variables, but in these problems the constraint is going to be written as, we'll focus on ones where the constraints are written as inequalities. So if you see the instructions, write the constraint, that means write an inequality. The objective function is the function that describes some quantity of interest, like profit or cost. So you have an equation like P equals or C equals. The region of feasible solutions, or this is sometimes called the polygonal region. Okay, and on a graph, this is the region of points that represent possible solutions to the objective function that satisfy all the constraints of the problem. So you graph all of your inequalities, and we're going to look at examples where you end up with this polygonal region. This looks like a polygon, and all of those points represent possible solutions to the problem, all right, or in this case like possible profits or possible costs. And then a vertex refers to a corner point of this feasible region. Here are the 5 steps that you will follow to finish one of these linear programming problems. All right, so in order, first we write the objective function. Now part of this is figuring out what the variables represent. Okay? And we're just dealing with linear equations, so you're just looking for 2, an x and a y. Next you write the constraints, figure out what all of the restrictions in the problem are. Then graph the constraints, and then find the vertices of that polygonal region. Right, so the vertices of all of those intersecting constraints. Okay, now why are we interested in the vertices? Well, this is a theorem that's due to George Dantzig, and he proved that the maximum or minimum value for the objective is always going to be at one of those vertices. So this was a huge theorem because it shows that you don't have to test all of the possible feasible points. So there are a lot of profits and costs that could still meet the limitations of the problem, and there are an infinite number of them in that region, so it's impossible to check all of them. So rather than just guessing or kind of blindly wandering around and hoping you have the best solution, we can know for sure just by testing those vertices. Now in real life you might have hundreds of constraints, so you might have, if we try to graph this, you end up with regions that have, they could have hundreds of points, or we start looking at things with more than just two variables. And then there are other advanced math techniques that can be used to find those key points. But for our purposes, we'll just look at regions that have maybe like three to six vertices, and that would just give 3 to 6 points to check to see which one gives the maximum or minimum value. Now once you have those vertices, we will substitute the coordinates of the vertices into the objective function, so plug in the values for x and y, and see which one gives the maximum or the minimum. Your book has a note, the solutions will not always be integers, so you might have to round the results. So depending on the problem, if x and y represent something like people, then you would need to round. If it's dollars, maybe you would just round to the nearest cent. Okay, that's an introduction to linear programming, and hopefully just through these videos we'll approach this from some angle and you'll start to get the hang of what this process is about and how we would do these problems. So in the next video we will talk about 2 examples and just go through the 5 steps in that process to solve a problem.